penetration of a thunderstorm presents certain problems which every pilot will have to face sooner or later. The objective of this film is to explain the preparatory steps which must be taken and the techniques which must be followed. In the thunderstorm clouds, the pilot may encounter cells, regions of strong vertical drafts and gusts. There may be heavy rain, brilliant lightning, moderate to severe turbulence. The effects of this turbulence on the pilot, on the attitude of the plane and the plane itself, are the principal considerations in flying the thunderstorm. The phenomena associated with a thunderstorm may create a mental hazard on the part of the pilot. You, as a pilot, must have confidence in your ability to fly the storm. It is important to be aware of the limit load factors of the plane you are flying. The psychological effects of fear are not conducive to good judgment nor to normal reactions. And so it is of primary importance to remain calm. No matter what type of aircraft you are flying, the procedures in general are the same. This pilot is returning from a mission. Static in his earphones warns him that he is approaching a thunderstorm area. Lightning flashes reveal that a line of storms lies across his flight path. Because he must go through, the following preparatory steps are essential. Tighten and check safety belt and shoulder harness. Turn on pitot heat. Adjust power setting for the desired penetration airspeed. This airspeed must provide good control in turbulence without subjecting the plane to undue stress. Check the electrical inverter for proper operation. Make sure the gyro horizon is functioning properly and check fuel. Turn on all lights for maximum protection against the blinding effect of lightning. Fix position accurately before entering the thunderstorm. Turn off any radio equipment that is rendered useless by static. Your VHF and UHF equipment will be reliable. Use speed retarding device as necessary. The technique used in the penetration of thunderstorms will be that of attitude instrument flying, based primarily on the indications of the gyro horizon. Pressure differential instruments are unreliable under the abnormal pressure conditions in a thunderstorm. For maintaining attitude, rely on the gyro instruments. The gyro horizon is the primary instrument for both pitch and bank. Once you enter a thunderstorm, stay on your course. Never attempt to turn back, even though the going is rough. Otherwise, your passage may be prolonged. To avoid temporary blindness from lightning, keep your eyes in the cockpit. Rely on your instruments for a picture of what the plane is doing rather than your physical sensations. When a gust strikes, ride with the punch to level the wings. Use smooth, steady control pressures. This will diminish stress on the plane. Up goes the nose. Again, ride with the punch, using smooth, steady pressures to restore level pitch. Another gust banks the plane. And again, easy does it. In maintaining level flight attitude, it is of primary importance not to subject the plane to undue stress. Gusts also affect heading. Attempt to maintain the original heading by using a minimum amount of bank and coordinated control pressures. Rely on a constant power setting to maintain the predetermined airspeed. Remember that an airspeed indicator is unreliable as a primary instrument in a thunderstorm due to changes in gust velocities, changes in pressure, and heavy rain clogging the pitot tube. After the plane leaves a turbulent area, check the altimeter and other pressure differential instruments. If an altitude correction is necessary, use a minimum change in pitch to avoid the possibility of entering another turbulent area in an undesirable attitude. Vertical drafts carry a plane up or down. No altitude correction should be made unless absolutely necessary, such as when the plane is close to terrain. By letting altitude vary, the effects of turbulence are minimized. Avoid over-control in all attitude and altitude adjustments. High airspeeds require small corrections of attitude. Low airspeeds require greater corrections. As soon as the instruments indicate that you're in a non-turbulent area, correct the altitude toward the assigned level. If required, adjust the power setting and correct the heading. Although a thunderstorm may be 25 miles or more in extent, the period of roughest flying will be relatively brief, since normally the turbulent cells are only 2 to 5 miles in diameter. Utilizing the proper penetration techniques, a proficient instrument pilot flying attitude will be able to carry out any assigned mission. When flight through a thunderstorm is anticipated, planning should start on the ground. Let's say you're the pilot on a flight that will take you from Jacksonville to Abilene. Scattered air mass thunderstorms are reported en route with a possibility of a squall line developing. One isolated air mass thunderstorm is reported in the area, so the aerologist checks the radar for information as to the movement of the storm. You recall the technical data for your aircraft and the recommended speed range in turbulence. So you study the situation carefully and decide to file VFR, though later you may have to file IFR. Soon after takeoff, you encounter the local thunderstorm. As it is isolated, you fly around it. A little later, a larger air mass thunderstorm appears in your flight path. The base is high above the terrain, and you can see through to clear sky on the farther side. And so you know that it's safe to fly under. You note the dark area under the cloud, which indicates the heavy rain and downdraft under the thunderstorm cell. You want to stay clear of it. So you select a flight path on the side of the trailing edge. As you go on, you see that the anticipated squall line has developed. It lies right across your flight path and is hundreds of miles long. You study the situation carefully, and you check with your radar operator. The squall line is too high to fly over. The base is too low to fly under safely. So you decide to fly through. You ask for IFR clearance. And you are assigned 4,000 feet. You know that in this situation, 4,000 feet provides a safe elevation above the terrain. At this altitude and below, you may expect minimum turbulence, no structural icing, and less possibility of encountering hail or of being struck by lightning. You order your crew to take the necessary precautions prior to entering the thunderstorm. The smoking lamp is out. Tighten and check safety belts and shoulder harnesses. Secure everything that's loose. Put on sunglasses. Apply carburetor heat as needed. Recheck de-icing equipment. Turn pitot heat on. Select best fuel tanks. Turn the automatic pilot off. Place your mixture control in rich. Increase propeller RPM to maintain engine temperatures, to get quicker reactions from power changes, and to get some additional gyroscopic stability. Adjust power settings for best penetration airspeed. Check the gyros for proper setting and operation. Turn cockpit lights on full. Fix your position accurately. Reel in trailing wire antenna. Turn off radio equipment rendered useless by static. Your radar operator studies the picture of the squall line that his scope reveals. Based on the location of shower areas as indicated by the radar return, he determines your best point of penetration, where the squall line is thinnest and the separation between shower areas is greatest. You always enter the squall line at a 90-degree angle. Since the squall line is hundreds of miles long but shallow, this approach will ensure the shortest passage. You may encounter hail during any penetration. It cannot be forecast. Unusual color of a thunderstorm is no indication that it contains hail. If you encounter hail, reduce speed immediately to the lower limits of the speed range recommended for your plane's flight in severe turbulence. Guided by the radar operator, you miss the areas of heaviest rain. Your job of flying attitude is simplified, and you soon complete a successful penetration of the squall line. Landing in the path of an advancing thunderstorm is hazardous, even though the airfield is in the clear. High surface winds and abrupt wind changes, which might be disastrous to a plane during landing, extend up to 5 miles in front of the advancing mature storm cell. The shelf clouds and the anvil top indicate the direction in which the storm is moving. The pilot should circle in the clear until the thunderstorm passes the field, which will take only a short time. If the field is radar equipped, the control tower will track the advancing storm and issue necessary landing instructions. Important as some missions may be, a pilot must have a wholesome respect for thunderstorms. The best technique is to avoid a thunderstorm if possible by flying either around, over, or under. It's a good idea to start planning how to fly through a thunderstorm area on the ground. Know your plane and its limitations. If you must go through, take all the preparatory steps. Keep your eyes on the instruments. Maintain proper attitude. Depend on the gyro horizon. Use smooth, steady control pressures. Maintain proper power setting. Stay on your course once you have committed yourself to penetration. Never turn back. Do not attempt landings or takeoffs in advance of an approaching thunderstorm. Successful flying of the thunderstorm requires thorough knowledge of your plane and of penetration techniques. Above all, it requires a high degree of proficiency as an instrument pilot.